Welcome to today's Explainer. We're breaking down a paper on making AI orchestration mathematically rigorous.
LLMs are great at text, but how do we make multi-agent systems reliable decision makers under uncertainty?
Right now, agentic systems seriously struggle with critical decisions like routing or stopping when costs are asymmetric.
The fix? Stop forcing LLMs to decide. Instead, build a Bayesian control layer right on top.
Keep LLMs as text generators. Let the orchestration layer track beliefs and maximize expected utility. It's a strict loop. Maintain belief, observe the agent's message, update the posterior, and then act.
First, define a latent task variable. This separates the actual decision target from basic next token probabilities.
The orchestrator updates its belief using this specific composite likelihood formula whenever an agent sends a message. See that alpha? That's the agent's reliability weight. It tempers evidence from noisy or dependent sources.
Let's look at multi-agent code generation, where different LLMs write, review, and test the code.
The orchestrator picks an agent and gets their output, treating it mathematically as a noisy observation.
It updates its belief on whether the code passes or fails, stopping when expected utility justifies it.
This expected utility policy actually prevents infinite loops and dynamically optimizes trust using those reliability weights. What about multi-agent deliberation? Picture a complex server outage where agents debate the root causes. Here, the latent variable isn't just pass or fail. It's a set of mutually exclusive hypotheses. The orchestrator tracks posterior mass across each hypothesis, rigorously weighting arguments from every single expert agent. Once confidence crosses a utility-based threshold, the orchestrator terminates the debate and escalates the final decision. This value of information trade-off determines which agent to query next, managing partial info totally seamlessly. From all this, the paper extracts 7 reusable Bayesian design patterns for production AI systems. Key patterns include task-level belief factoring, treating messages as observations, and pooling evidence for correlated outputs. You also need belief state distillation. This compresses interaction history, keeping latency and context windows perfectly manageable. The big takeaway? Bayesian orchestration demonstrably improves decision reliability far beyond standard LLM heuristics. Future work means building rigorous benchmarks to measure how Bayesian policies outperform baseline heuristic orchestration.
So, ditching simple heuristics, how will you implement utility-aware Bayesian policies in your next agentic build?